microelectronic division, and we have some special problems in terms of simulation. We are working in a special device, what we call FinFET device. Is a vertical transistor that could be the next generation devices. And in this case, you have a totally three-dimensional transistor. The problem is CPU time, right? How this performance of the device can impact our research results.
What we do here, and in my group here at this department, is essentially large-scale atomic simulation. And we are the people who really complain about the computers because we are never happy with what we have. Today, people have succeeded in developing field effect transistors using nanotubes. Now, let's say the hottest field in this fundamental material science is graphene. 3 years ago, people from Manchester University succeeded in getting this one layer of carbon systems. And as a result, these graphene systems are very interesting systems, a two-dimensional atomic system that many people think you can develop electronic devices based on that. And as a result, you can have, for example, optics integrated in this device, which is something that's quite a challenge for silicon technology. Here, when we do science, we are always taking opportunities, and in diamondoids, we are always also studying one of these diamondoids called amantadine, which is it's a molecule which is used for treating influenza.
I'm going to give you a little overview of our CEL University program. In 2006, we announced our first CEL blade. In September 2006, we announced the QS20 system. It was available for sale. In November 2006, we had the CEL University workshop here in Sao Paulo, where I met some of you. And then a year later, we announced the QS21 CEL blade. And just recently, this month, we announced the QS22.
Then we have assisted programming. We have various software frameworks that are available in the SDK, and of course there are some software frameworks available from other vendors. And then we have complete development environments and libraries, software development tools from some of our industry partners that can help simplify the development of CEL software. We've been collaborating with schools that have delivered proofs of concept. A lot of schools conducting new research. A lot of our schools that we work with have delivered a lot of assets to the open source community. The CEL Centers of Competence has also been a key part of our strategy to evangelize CEL, to spread the word, get other people excited about using CEL. And we're here today to welcome University of Sao Paulo as our newest Center of Competence, IBM Center of Competence, to continue our CEL evangelization efforts here in Brazil and all of Latin America. Depending on ultimately how large your configuration becomes here at USP, you can always take code that you've developed here and run it on Georgia Tech's cluster. They actually let you dispatch jobs on the entire cluster, so you can test the program out on a PS3 or one single CEL blade, and then ultimately run it on up to 14. Adding your name to these charts and showing the rest of the world, all the good stuff that is going on here at USP itself.
Sergio is working in CEL for almost 5 years. I collaborate with him in high-performance computing. So it's very exciting to have access to this state-of-art technology. In VR, we are interested to conceive what we call ultra-high definition immersive environments. We will show a prototype with 2 projectors, but we will deploy in August a system with 12 megapixels to a museum nearby. And we will display images in ultra-high definition, 2K by 16K pixels.
We work with high-performance computing and networks since the 1990s. Recently, we focused in multi-core, multi-threaded architectures and dynamically reconfigurable architectures, mobile computing, computer vision, and wireless sensor networks. Regarding CEL Center, Our mission is to disseminate CEL multi-core architectures and embedded and high-performance computing applications at Brazilian industries and research development institutes. Provide research and support to scientific engineering community at Escola Polytechnic of São Paulo. And now we are opening a new stage of these activities using the Blade Cell KS21 from IBM US.
Another field that could use this kind of infrastructure is the development of neural architectures in which the rich dynamics that you observe in the biological systems is embedded in the models. And this kind of architecture requires a lot of simulation and a lot of computer power. So the idea is to blend chaotic dynamics and order dynamics to improve the performance of the neural architectures.
Basically, the mission of LTC is to enable IBM products with Linux, right? We, of course, have other missions that is make Linux better. Linux is open source. If we make Linux running on IBM products, we will also make Linux better on other platforms as well. In 2007, we started a great work with this LTC Brazil team that is working with CEL, with the universities, trying to spread the knowledge of CEL programming and CEL architecture among the Brazilian universities. So we have more than 10 workshops and presentations during 2007 with more than 200 attendees. That's what I have to talk here. Thank you. It's open source.
Yeah, yeah.
It's on the
yeah,
net.
Yeah, yeah, that's why it's so important.
And there's a version for x86 also. So.
Yes.
Sensor network and send information to. So we only transmit not in image but
I see.
we are using DSP, Blackfin, but we are
You know, IBM for the last 2 years has worked extensively with academia, and it's part of our strategy to help, you know, evangelize CEL and you know, spread the word and get other people to adopt the technology. And this is our first center in the Southern Hemisphere. We have a couple centers in America. We'll be having one in Europe. So this is our third official center, and there's a long history already here at University of Sao Paulo doing research on CEL, and we're very excited to have it continue and help people in local industry and your other university partners, you know, get on board. We like the focus you have on applications. We're at a point now where to really make CEL successful, we think in the industry, is to show useful applications running on CEL. Number one. Number two, we hope that USP works really hard towards the evangelization, and that's really not asking much because you've been doing that. You know, you have your website, you've been active with incorporating CEL into your curriculum, publishing, and you know, we want to see that continue.